Welcome back to the second part of the SFSCon, the developers track. So let's quickly start with our first speaker. He's coming from a very known company, the Red Hat. It's one of my favorite Linux distributions, perfect. And he is going to talk about how to minimize the impact of flaky tests on CI pipelines. So let's welcome Daniel Hiller and from Red Hat, and his talk, Squash the Flakes. The floor is yours.
Yeah, so thanks everyone for attending this talk for mine. I'm really happy to be here. It's the first time for me, and it's a great city. Thanks again for inviting me. So, thanks. My talk will be about flakes. I guess that some of you might be wondering what that is. I'm just going to give you a quick overview over the agenda. This is, of course, the obvious about me. Then the what is a flake? How do we want to minimize the impact? So I'm going to talk about the flake process, how it exists at our company, and how we established it. So I'm not saying that this is a silver bullet that we have. It's just one way of dealing with this problem. So I'm also telling you a little bit about the tools that we leverage, partly self-written, partly leveraged from other open source projects. And I'm trying to give a little outlook on the future of how we want to improve our own process. And maybe some pitching of the project itself, probably. I hope that's okay, since it's open source, right? Okay, and of course, questions and answers. So about me, I'm a software engineer from Red Hat. I'm inside the Red Hat OpenShift virtualization team. I'm responsible for maintaining kubeflow CI, and I do automation in general. Let's dive right into the topic of a flake. In case you don't know what a flake is a test that in consecutive runs either fails or passes without any change to the source code, which of course is a problem if you want to have reliable CI results. So I have seen a survey on flaky tests, which is a meta survey of a lot of surveys that have looked at data about flaky tests. And I think, I don't remember the complete numbers, but I think there must be about 70 surveys that have been part of this survey. And it's called a survey of flaky tests. For everyone who's interested in that topic, please look at that. It's a lot of data, it's really interesting. So from this survey, I'm going to cite that 97% of the flakes were false alarms, and more than 50% of the flakes could not be reproduced in isolation, which of course leads to developers just ignoring the problem, which is a bad thing to do. So I hope that this is funny. I don't know. So failed test runs should normally give us a signal whether the code is stable or not. With flakes present, of course, you lose that signal. And thus, if you are having flaky tests in a test suite, this can ridicule the complete process. So what we have experienced, what has been happening while flakes were present, actually, to just boil it down to what actually happens is that developers are getting annoyed by this. Since the thing is, they have longer feedback cycles, so they sometimes just retest everything because they don't bother with the problem of being flaky. Sometimes they even don't know how to fix it probably. If you have like some advanced things like batch testing or something going on, this of course, one flake can ridicule all this acceleration effect that it has. The worst thing, or another bad thing about that is of course that people or the developers lose trust in automated testing, which is actually what shouldn't happen. But it happened. So how do we want to minimize the impact of flaky tests? We are trying to locate flakes as soon as possible, take them out of the set of tests that are being executed in CI, but only for as long as necessary. So we have time to fix it, so we can bring it back in, because every test should have some value. And every test, of course, someone has thought about this test and has put noticeable work inside that. So we don't just want to throw it away. That will be the alternative, right? Just throw every flaky test away. But yeah, you don't want to do that because there must be something that is valuable with this. So what do we need for that? We need a couple of things. First of all, we need a method on how to remove a flaky test and put it in another set of tests that are not executed during the CI runs. So the gist of it is that you have some kind of flag on a test whether it is flaky or not. So you can move it out of the whole test suite at any time if you need it, if it gets flaky. Of course, then also you need a test report that would tell you which tests are actually flaky or not. But I'll get to that later, how you can find that. And of course, lots of data, so you can somehow decide whether, how or when you need to fix it. So either you would take it out right away, or people would even be able to fix the test right away. So this is the interesting thing. What you see here is a lot of test lanes. These test lanes, if you look at the top of this one, let me see if that works somehow. This one is the commit ID, right? So you see all these test runs have been executed on the same commit ID, which brings us, of course, to the conclusion that at first some tests failed and then all passed, which brings us, of course, to the idea there must be flaky tests inside. And that's how we find them. So looking at test results and trying to identify the bad test runs with flaky tests, and then condensing a report out of that, or a couple of reports. So in general, our flake process works like this. We have regular meetings where we look at the data, where we see the flakes, where we decide what we do on those, and then we hand them over, because we are not the responsible team for fixing the flakes. We are just the messenger, right? We are just telling people, okay, this is a problem that you need to fix right away, please. And of course, then we try to bring those flaky tests, as soon as they're stable again, back into the test suite, so that the value is not lost. So this is, in a nutshell, the pretty easy thing, so like keep it simple, right? So you would just have some attached label, which is just inside the test description, there is a label that notifies that the test is flaky and that it shouldn't be executed during the normal runs. So we are distinguishing between pre-submit skips, so where the quarantine tests are not executed, but we also have a suite of periodics where we see how stable those quarantine tests are, because we need that as feedback signal so that we know whether we can bring them back in. So the next is the general flake report that we have, which tells us by some kind of heat map where the action is going on. So the more red, or the redder, I don't know, I'm not a native speaker, that is, the worse the problem is. So if you see, like for example here, or here, these are the action spots, right? This is the test lane that is failing a lot. And this is the date on which those failed somehow. So we have two axes of aggregation, which gives us a good enough overview so that we can handle on that. So the next one is the top most recent flaky tests list, where we can just see which tests are making the top of the list. So which tests do we need to act upon right now? And then we have the detail report where we can look at what exactly is going on. So we actually can see in which test run, which test has failed, so that we can directly dive in, look into the test logs, and see whether that, so the truth is, this might not be a flaky test. It could also be a general production bug, right? So you could also have some production bugs written, and you need to separate them from the flakes. We are just talking about flakes. Of course, these we also communicate to the other teams, right? So they need to know whether there is a production bug. But we want to separate those so that we have clear guidance between flaky behavior and flaky tests, which I would want to separate. The flaky behavior is a bug in the production system. The flaky test is a thing that is only happening on the testing side. Yeah, of course, every project needs statistics that we want to show to the general users, but yeah, I'm just kidding. This is just also a general production metric about how we're doing. So things like merge queue length, average time to merge and so on are essential metrics for us so that we can see how we're doing, whether anything is wrong on the large scale. Of course, another thing that you need to bring tests back in, you need a list of the flaky tests. If you have those tests, those labels hidden inside the source code, you might not find them right away. Sometimes a grep might not really bring you to the actual action and how to unquarantine them. So you need a general list of tests where you can just look at so that you can then later on look at some data, how stable they are. And that's actually what we are leveraging another tool for, that is TestGrid, which you might be familiar with because Kubernetes is also using it. They have TestGrid, they show test results from everything. So we are inside the Kubernetes TestGrid, so we can leverage just this one. So there you can drill down from every test lane to every failed test. And yeah, one other thing that we wanted to, or that we are establishing right now is something, of course, we want to catch flakes in advance. So the best thing would be that flakes wouldn't even enter the system, right? So we are trying to run all tests that have been changed during a PR and running them in random order, which is also interesting because you might know test dependencies are a problem. If you are running tests always in the same order, there might be hidden test dependencies that when you suddenly randomize the order, they might fail. Of course, we want to change that. And also the study that I mentioned previously tells us that on average, more than 80% of the flaky tests are being discovered after 5 times. So that is also the reason why we are exactly running those tests 5 times. Yeah, so and this, I just can skip that. That is just a search tool so that you can look at a couple of failed tests probably. In a nutshell, the essence, I think, is due diligence. You need to be diligent with the things on revisiting everything. So you also need to have the process to due diligence on the follow-up on tests. Then also this triaging, like what are the worst problems at the moment, where do we need to handle, and derive actions from that and hand these over to the dev teams who are actually responsible for fixing all this. Yeah, and of course, at some point to take back the stable enough quarantine tests. Yeah, the future is, of course, more data, more tooling. So we would want to have more dashboards and a better overview of everything that is somehow going on inside the system. We would want to have a better separation of how the flakes are can be deduced to a special team that would be handling them. Yeah, and of course, the ideal thing would be to just creating automated quarantine PRs, but we're not there yet, of course. So because there's flakes everywhere, right? By the way, just one fact that I just wanted to tell you, more than 50% of developers are handling flaky tests at least on a monthly basis. So please think about that. And I think that's me. Thank you.
Thank you very much, Daniel. We have 30 seconds left. Is there any question? No questions so far? Okay, so thank you very much, Daniel. If you want to discuss something with him, I think you're around at the conference and happy to discuss them.
Thanks.
Okay.
It's been a pleasure. Thank you.
Thank you. See you in 5 minutes. right, welcome back. So our next talk will be a comparison of open source function as a service technologies. So with this talk, we should get a better understanding of the landscape from the experience of Andrea Mancini from EO. The floor is yours.
Welcome, everybody. Good afternoon. As mentioned, I'm Andrea. I work in a company that's called EVO. Today, I want to present to you our journey, let's say, across different open source fast technologies. What are the challenges that we faced in moving from one to another, and why actually we moved from a technology that was satisfying us to another one. First of all, I would like to start with a question. What is a master of transformation? As you can imagine from the video, our company is not a classical digital company in the strict sense, because this was a video made by our marketing of the last product that the company released, and actually the company builds lights for outdoor lights. Actually, outside of Noi, there are our lights, and inside the company, there is a small unit that is responsible for the digital transformation of this company, and in this unit I work on. And this video is a metaphor because on one hand, we need to be very fast in transforming as a digital team to accommodate all the requirements that the company gave to us. And it's also to show you what we had to tackle every day, because that was only one product that we have in our catalog, and it can be configured in a plethora of ways. And the first use case that we need to tackle every day, that we need to support, is a product configuration from a customer. A customer can select a lot of configurations, a different configuration. Imagine you want to define a light pole that you want to put on a street. Then you need to decide how high the pole must be, the current that you want to pass through to the electronics of this device, and other things. Actually, as you can see in the slide, what we do is automatically calculate some constraints starting from a specific configuration, like, for example, the current that you need to emit to allow the customer to give a luminosity that is constant across time, considering also degradation of the electronical components of a light. Then we need to extract driver data from driver datasheets and datasheets for other components. And also we need to calculate the cable specification, because you can imagine, according to the height of a pole, then there will be the need of specific cables, like, for example, for other lights, like ballasts or things like that. You need probably a less complex cable specifications. These, of course, are interrogated by API requests, and they interface with a database in which we have all the datasheet and the information of the products. And this is the first use case that we need to. Okay, sorry. Better? Yeah. Okay, thank you, sorry. And I was saying that this is the first use case that we need to cover every day. And the other use case that we need to cover is actually when a customer wants to actually configure a project, starting from a CAD, a drawing of an area. Like, for example, you can imagine an airport. You need to design the project, and the project is based on the landscape of an airport. And then this needs that we need other components, like, for example, the handler of this drawing, and also the analyzer of the area in which you need to put your lights, because there are environmental constraints, there are physical constraints, and so on. And also, of course, as mentioned before, also in this case, you need to calculate the cable specification for your light, because Every single light that you want to apply then needs specific cables. Why we need FAS in this case? Because actually we need to fast transform our deployments, let's say our software, in order to support new APIs, new products, new physical calculation actually, because most of the operations that we need to do for providing automatic configuration is actually do physical calculation, optical calculation, and so on and so forth. We need actually to manage the load in an automatic way, so having mechanisms to permit auto-scaling or downscaling when needed, and also using interruptible workloads to reduce the cost that we have to pay in order to maintain this infrastructure. Our first implementation of this was based on OpenFAS. OpenFAS is an open source framework that allows you to actually focus specifically on the code of your function rather than the infrastructure that you have. For us, at the beginning, was very easy to deploy the OpenFAS and our function, implementing our functions on Kubernetes. So because also the documentation is very well maintained, it's very clear, and so on. So the learning curve is very easy at the beginning, specifically for this framework. As you can see, you don't have a lot of components. You have some that goes on top of Kubernetes, like for example, you have a gateway that intercepts the REST API request that you get. You can get metrics from Prometheus in order to understand if you need to scale your functions or not. There is the alert manager that actually is responsible for scaling the function. And then you have an OpenFAS provider that is one that forwards your request to the specific functions. Functions are basically Docker containers in which you run your code. Our functions here basically are mathematical routines that need to compute information related to, as I said, driver data, cable specification, optical lenses, and so on. We actually were very satisfied about this because the system was very stable, actually. We didn't have much problems, actually, in building up this thing. But what happened? At some point, there were some changes in the OpenFAS business plan, actually, and some features that for us were fundamental, like, for example, having multiple namespaces. As you can imagine, we use Kubernetes namespaces for separating between customers, for separating between staging environment, testing environment, and also productive environment. And at some point, I decided that they wanted to move this feature to another subscription plan that was not free anymore, and it was paid. And at the same time, they started to remove the old images from their Docker repository. Images that were older than 90 days were removed, so forcing you somehow to upgrade your system. At this point, you might ask, okay, you were really satisfied. Why don't you pay then for the subscription if you need some specific features and so on? Well, actually, the answer was, the funny answer is that because we wanted to experiment, actually, and we wanted to suffer to see how the migration could go. And the serious answer is that sometimes you need to play with a budget that is very strict. So it does not allow you to go to pay for some services that you can have for free on another framework or on another system. And what we actually do was to try another alternative. And we moved to Knative. Knative is not actually dedicated to function as a service. It's a more, let's say, generic platform for serverless workload on top of Kubernetes. It has more components, actually, than OpenFAS, because as you can see in the image, in the slide, you have more components, actually. So the learning curve at the beginning is quite steep. Let's say you are not focusing anymore only on the code of your function, but you need also to tackle the difficulties of deploying these new components on your infrastructure. a good thing is that it's flexible and it gives you the freedom to customize it with your own custom rules and so on and so forth. How our migration journey went, actually, because to be honest, we are a very small team, because working on this project, there are 2/3 persons, so it's not very easy. And we started from a Kubernetes cluster in which we had deployed our products, let me say, the configurator for the projects and the configurator for the projects, and also the functions that were deployed on top of the OpenFaaS components. This was connected, was talking with the central database with all the data. What we actually decided to do was basically to create another cluster, install Knative on top of the Kubernetes cluster with some difficulties, because, to be honest, at the beginning it was really difficult to go through the documentation of the framework to understand how to deploy the various components that we needed to deploy. And then what we decided was, okay, let's bring let's say the more robust component that we have and move them to this new cluster based on Knative. Some sort of canary deployment with the traffic that is routed to a new cluster. Also here we had a couple of problems because we were not able to play very well with the autoscaler of Knative and so on, so we had troubles at the beginning. After a while we were able to actually make the system robust and strong enough to actually move everything to our new cluster. And this required some time, of course. We couldn't, of course, switch off the old system to play with a new one, because, I mean, we had to support the company and support the project and product configuration of the customer. What was then our experience? What we actually passed through on this migration? Well, the first thing is that whenever you play with an open source software and there is a change of license or a business plan of a specific framework, then it can be a problem. You need to actually adapt faster, as I said. As I said before, you need to adapt quickly, because then you need to transform what you have to go in another direction. We actually noticed that moving to a more focused on FaaS framework to another one that is more generic was difficult in terms of reading the documentation itself. Navigating through the documentation of Knative was not very easy at the beginning, because sometimes it's too high level, sometimes it introduces a lot of new concepts, and we actually, in the end, we were interested in function as a service. But then here, playing with something that is more general can create some problems. And another thing that we saw is don't be too tight with a technology or with a framework or with a tool in general, especially in our case with FaaS, because in the end you need to be very good and very fast in changing, adapting to the environmental changes, let's say, also in this case. And yeah, this was basically our journey through these technologies. Right now, I think we can say that we succeeded in this migration, because, I mean, the tools are on, the people can use it, so we are pretty satisfied about this experience that we did. Thank you very much.
Thank you very much. And yeah, very interesting to hear how the change of, let's say, the paid plans or free plans impact on the company. So are there any questions here?
Please.
Can we have a microphone?
Thank you. So you said that there was some cost in order to do this migration, change technology, not monetary cost, but indirect cost like time lost and everything. Do you have some tips on how to balance how to make a strategy decision where to save on the licenses cost and have more indirect costs, or to go with a commercial solution and have some license costs, but less indirect costs.
Okay, it's a very nice question, by the way. I'm not sure I'm the right person to answer because I don't really manage directly the costs. I can tell you that in our case, the migration was dictated by the fact that moving to a paid plan in that specific moment of time was problematic for our specific division. As a general tip, I can tell you that, first of all, as I said, don't be too tied to a technology. Always be somehow free to experiment with something new without disrupting the normal work of your tool, of your application, or whatever you need to run. I think, generally speaking, it's always a matter of costs, I would say. And then you need to measure how much you want to experiment, try to understand how much difficulty it is to embrace a new technology, reading the documentation, try to study. We knew in advance, I can tell you, that moving to Knative was, could create problems because it has a steep learning curve in comparison to OpenFAS. We knew it in advance. But we didn't have at that time, except for the budget constraint, we didn't have any other constraint, timing and so on. Because actually, we put some workaround in place to make the other version of our, let's say, product working with the free version of OpenFAS, and then we move slowly to Knative. Maybe we can discuss later. I can tell you some more details about this related to the process that guide us in this decision.
Thank you, Andrea. Thank you very much.
Thank you very much. Thank you.
So in the developers track, we have a break now, and the next talk will be at 15:20, so 20 past 3. Enjoy the other talks and see you then.
prova sì, prova sa, prova sì, prova sa. Facciamo 2 prove anche con l'headset.
Uno, due, tre, quattro, cinque, sei, sette, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, no. Considera una persona normale sta qui. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Ma questo è l'impianto di sopra? C'è un'equalizzazione su questo impianto di sopra? C'è un'equalizzazione su questo impianto di sopra? Flat? Sei sicuro che non è flat sta roba? Ah. Cioè. Scusa, riesci a prendermi una base delle tue? E tenermi la base delle tue appesa con il tuo impianto? Possiamo mettere in parallelo. Questo è il tuo impianto. 11. Ok, questa è la tua. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sono tutti e due. Perfetto. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Se faccio così mi sento di più, se faccio così mi sento di più. Allora, due microfoni. Questo è nel tuo impianto, questo è nel coso, lì è spento. Se io faccio questo è il microfono nuovo che abbiamo messo di là. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. L'hai tirato su dal di là? Vado a tirarlo su.
Sì. Test di nuovo. Ma c'è sempre questo...
Ti ho tolto da di sopra. Ne vuoi di sopra, vai?
No, di meno. Perché davanti si sente molto forte questo eco. Quindi da un disturbo parlando si sente con un mezzo secondo di ritardo, mi sento, quindi...
Ok. Adesso provo questo, allora. Ok, provo adesso.
Test.
Perfetto.
Test. Ok. 1, 2, 3. Puoi abbassare un po'. Perché tanto se parli lì... No, vuoi abbassare un po' il volume in sala. Ah, non hai le casse quelle? Ah, capito. Va bene, dai. Schon. Test. Okay. Welcome back to the developers track of the SFSCon 2023. after this break. I hope you had a great coffee. So we continue with the next talk, and this will be a talk from Simon Dalvay. He's a staff member of the Neue Tech Park, Tech Transfer Digital, and he's mainly working on as software architect on the Open Data Hub. But today's talk will not be about the Open Data Hub, but about F-Droid, the place for your FOSS apps, and why you should, I've written commit, but submit your FOSS Android app to F-Droid. Welcome, Simon.
Thank you very much, Martin, for this introduction. So today I will present you F-Droid and what effect it had on my applications and how to submit applications on F-Droid. So first, few facts about me. I enjoy FOSS happily since 2013 when I was introduced to FOSS software in high school. And then around 2018, I started to create mobile games in my free time as amateur game developer, and I started with libgdx. It is a Java library where we can create Android and also iOS apps, a little bit difficult, but you can do it. I created 3 little games, and then since 2020, I use the Go.engine. It is also an open source engine, and I think one of the most used today. And I created 2 games, and I'm working currently on one, the one with the question mark. Okay, so F-Droid is actually an application where we can download Android applications that are all open source. And it is a non-profit community-run project, so only volunteers work on this project, and there is no company seeking profit. So you can be sure that there is no data that gets pulled from you or sold or something like that. So it is free to use and also, most importantly, free to publish. Because, for example, on the Play Store you pay $25 once, on the App Store $100 a year. That it's not a problem for a company, but maybe for a community project or hobby project, it's still quite a money. So F-Droid gives you the possibility to publish your games completely for free. So some features about F-Droid and anti-features, I will explain you what that is. So one feature is that everything is built from source. So of course your application needs to be open source and the source code gets pulled and then built and uploaded, but also all its dependencies. For example, in my case, I have to pull the Go.engine code, build the Go.editor, and then from there, open the application and export the game. So if you have third-party dependencies or something like that in your application, they need to be open source and be built during the CI process. So you can't just download them from a pre-built repository, you have to build them on the fly. And they have a strict inclusion policy where apps need to be open source. They don't allow, I don't know, they allow ads, but they're not so welcome, or there are some features they don't like. And especially some features are called anti-features, and then on the App Store you see that that application has these anti-features. For example, here the first one you see is if they use non-free network services, like for example, some of you know the NewPipe app. It's an alternative YouTube client. It's completely open source, but it completely depends on YouTube. That is a non-free server application. And so you see that this application is not completely free. Or for example, that it uses non-free assets, or also it has currently vulnerability issues. For example, on Google Play Store or App Store, you actually don't see if this app has vulnerability issues. On F-Droid, you can see that. And another big feature I faced using F-Droid is the visibility. For example, on the Play Store, you have millions of apps, also on the Apple App Store. And on F-Droid, currently there are around 5,000 apps. And so you don't have much competition, and so you get much more visibility, and the users using your app are also much more technical and know how to contribute to your project and everything. Then you can also get reposted on several websites. For example, I saw Fostroid.com, where several open source applications are listed, and mine got listed there because they're available on F-Droid. Or they also got added to some awesome lists. These are lists, you may saw already some, that are collection of useful software or documentation, and in these lists, my games were listed after being added to F-Droid. And also other open source communities, for example, on Mastodon I got a lot of feedback, or on Reddit, on Lemmy, so the impact was really high for me. And here to see the impact in numbers. So before F-Droid, I had published 5 games on the main app stores. And on GitHub, there was nobody really cared that it is open source. And I mean, I can understand that normal users using the main app stores don't know what open source is, neither what GitHub is or a Git platform. So the impact was really low, to 0. And after, I published my 2 Godot games on F-Droid, and I think it's now nearly 1 year, and I got 33 issues open for pull requests and all these GitHub stars, emails with feedback, problems, also just, yeah, your game is awesome, thank you, or something like that. That's really nice. And Mastodon posts, and also some donations came up after publishing it on F-Droid, and they always said, thank you for creating games and making them open source and available on F-Droid, because there are few that do it. And of course, these are tiny numbers, but for a solo developer, it's still quite high impact, and it motivates me a lot. And now let's see how at least I was able to publish my games on F-Droid. There are different ways to do it. This is the one I did. So you can fork the F-Droid data repository on GitLab and create the build metadata file, add some metadata to repository, then you create a merge request where the CI runs and people, the volunteers on F-Droid, in case if there are problems or something like that, contact you, and then you hope that it builds, because since you have to build everything from source, it takes quite a time. For example, in my case, building Godot and the app and everything took nearly 2 hours. So you build it, it fails again. Like you can also do it locally, but I was not able, so I always used the CI. It took me 2 weeks for the first game, then the second game, it was just a few minutes. And if it doesn't work, there are really nice and kind people from F-Droid who can help you and will help you, and it's a really nice community, so I will have to thank the F-Droid team. And then, of course, once you have built this build recipe, or maybe you find already one that is done, you can create your new app and repeat everything from point 1. You can also, if you are maybe not technical and you see the source code or see open source code and don't see it on F-Droid, you can also do a request for packaging. So you open an issue on a repository, and the people from F-Droid or the volunteers will create the build file for you. So for sure it is much slower, but you can also publish apps without actually knowing how to code. And now let's see the files, a quick view in the files you have to create. So this is the metadata file in the F-Droid data repository. So you have, this is from my game Pocket Broomball. So since I have non-free assets, because the icons of the teams in the game are copyrighted, I don't have the, I mean, they are not free assets. So I had to add this anti-feature tag. Then you name the category, the information of the author, the websites, and everything. Then in the second part, you define the build part. So here, you really say how the app should be built, all the single steps that need to be done. And here it's important that you choose the correct source lib. In my case, it is Godot. So if you have a Flutter app, you put Flutter here or whatever. And then the build steps here, I cut it out because it's quite long, but it highly depends on the framework you use. For example, I saw some Flutter apps, there is just Flutter build or something like that. Here I need to build Godot, this was quite complicated, but it highly depends on what you use. And then on the last lines of the build metadata file, you put how the F-Droid server should check for new versions of the application. So in my case, I choose Git tags. So every time I publish a new Git tag, F-Droid, I think they run once a day a check where they check every repository if something new happened. And then they get the code, build, and publish the new version. So I actually don't have to do anything except to tag the Git commit. Because on App Store or Play Store, you have to upload the application, say what changed and something like that. And here you have to do some things I will show you later, but not much. So, because actually here, this is the metadata directory you have to create in your repository. So it contains, you can translate it. Currently, I just have it in English. And there you have to add the change logs. That's the only thing you have to add at every version, what you changed. Otherwise, you can add, of course, the screenshots, the icon, the descriptions, and that's all. You don't have to add much more. And yeah, that was all. I firstly want to thank the F-Droid team for making this great application, and then thank you all for your attention. So here you can find my games.
Thank you very much, Simon. Yeah, that's awesome. So you build your own games there and put it and distribute it there. So
Yes.
We have some time left. Are there any questions? There's one question over there. Do we have a microphone?
Yeah.
Oh, sorry. First one here.
Have
Can
you
stand
worked?
up, please?
Sorry.
Stand up. Thank you.
Have you worked with reproducible builds on F-Droid?
One of the volunteers got to me about reproducible builds. I checked them out. I didn't really understand how it works, so I didn't create one yet, but it's on my to-do list. So if you did it, yeah, we can talk later, okay. Thank you.
I am a user of F-Droid, and I'm very happy about it, but I wonder about the commercial sustainability. The other repos has millions of apps. Most of them are spyware, I'm aware. So we do not need millions, but the man time that is needed to do that, it's only made by volunteers. And can we ensure that it will go on in the next years if the amount of users is increasing?
Well, I don't know exactly how the F-Droid team handles financial things and everything like that. I know they have an open collective account where they collect money to sustain their project. And I know that they have some issues. If this would scale to maybe, I don't know, 20,000 apps in a year, they would surely have problems because currently they sign every app manually. So there are some things, I know there are some things that currently are difficult to handle if there will be a high number of applications, but I can't give you much detail about this. Welcome.
Other questions so far? There's one.
I just wanted to ask if I'm not I don't know, I've never used F-Droid, but in the build process you can also like build like a progressive web app or something like that. So can you let it be packaged by their tools, or are you limited to some specific frameworks that you can use, or you can do anything? I mean, can you comment about this? Thank you.
I don't know exactly how many frameworks and the type of application tools they support. They have some pre-built stuff, and maybe if your progressive web app uses some specific technical part that is not available, they surely can help you to get this done. or maybe you can contribute, but okay.
All right. Thank you very much, Simon. If you have more questions, Simon is here, and
Yes.
I think he's happy to answer those questions. See you in 5 minutes. Thanks.
Thank you.
So let's continue. Our next speaker is João Francisco Lino Daniel from the Free University of Bolzano. His talk is about microservices and why they are not always the best option. So what we do, writing a monolith. So João will talk about how to avoid that microservices will kill us.
Thank you. Good afternoon. Thanks everybody for your presence. Just a quick mention. My name is usually very easy to pronounce back in Brazil. Here I just learned that it's not so much. So if you want to address any question by name, you can call me Jay or Francesco, whatever fits better for you. So yeah, I come from University of Bolzano, and I'm very thrilled to be here today. It's a very big event, so I'm honored to be here. And so let's, oops, what happened? Okay, thank you. So let's dive into the talk. Don't let microservices kill you. Okay, so what does it mean? I think we'll discover along my talk here. So tell me if I'm much crazy here, if I see this scenario more often than we should. So we are always fighting between developers and architects, and there's like a back and forth dispute here. So developers say that software is key to the company's value, so we want to deliver value via software, so it's better to develop as much as we can. But on the other hand, we always have the architect or someone wearing the architect's hat saying, okay, architecture helps to improve the quality of the software, so don't go straight ahead developing. But on the other hand, we want to follow cycles of experimenting, having feedback, improving, and continuously repeat. So this means let's write code, right? But then if you reckless develop, so your code might have some depth and some problems. Okay, so the first question here would be, okay, how do I design some software that is future-proof? So how can I design something thinking about this process of development that typically is very long, very, takes a lot of time. So, okay, the solution very quickly here is to design an open architecture. Or we could post this same phrase in another wording that would be learn how to escape from its locks, as much as we can see in this picture here of this magician with the tricks and the locks, okay? So how can we escape these locks? And in this talk, I'll talk about 4 steps, and they are represented by these very nice images that I could generate using AI. So let's see. Step 0. Don't let microservices kill you. Yeah, so I said 4 steps, but I begin with step 0 because, yeah, I'm a programmer. I index by 0. So how do we avoid microservices killing us? What does it mean? And why is this the title of the talk? The idea is to begin the project using a monolith at first. So follow a monolith-first approach, because monolith is well-known architecture, it's low in complexity, it's easier to develop, so it's faster to begin to deliver value with your software. So in terms of architecture, it's a more suitable first strategy. Okay, so what is the step 1? So the second step, step 1, is to add a single entry point for your backend, because if we are talking about a web project, typically you have a front end, might be separate from your backend. So the idea is to add a single entry point for your backend. But your backend already has a single entry point because it's a monolith. So the idea is actually to place someone in the middle of the front end and the backend to manage this connection between these 2 pieces, because this gives you a lot of flexibility, as much as you see in this in this illustration, you have an amusement park, and you have all the fun activities you can do inside the park, but you only enter the park from one single entrance where they can check if you have the ticket, where you can buy the ticket, where they can see if you have any improper materials to the park, such as weapons or such things. So you only check these things at entries, and then you are free to roam around the park. And the idea here is to do something similar with the architecture. If you have a single entry point, something like a gatekeeper, a gateway, something like that, then in the future your backend can become microservices. You can evolve to microservices because your front end doesn't need to know anything about what is behind these entries. And okay, this is better, you are separating better the responsibilities. The client doesn't need to know much from your backend. It's also good because you can offload your backend from some cross-cutting responsibilities or issues to this gatekeeper. So let's move on. The step number 2 is to define clear boundaries. And again, this could be step 1 and step 2 be the gateway, because in the end, the gateway is actually a boundary that is actualized in code. And the idea of having boundaries is actually to organize your entire application, not only talking about specifically code, but you can have something that is beyond code. So the idea is you have your backend at the beginning, you have very few lines of code, few hundred lines, but the idea is instead of putting all your abstractions, and I don't mean necessarily classes, because sometimes you are using other paradigms, but the idea is instead of putting them to interact directly, create a boundary, create a module, create an interface, for example, so that you can hide some details behind this, this boundary, so you can have more flexibility to evolve different parts of your application. As a consequence, with this, you reduce coupling, you enable so much more things, such as a remote proxy. So you have a module that is going bigger and more important in your application. If you have an abstraction, if you have a boundary there, you can extract something, and this could become your first microservices that surrounds your monolith. So this kind of boundary enables these strategies. Step number 3. The idea is to use the domain as the first boundary. So if we are talking about a big or a medium-sized application that might have some different areas in the business rules, the idea is to find the different sub-areas and use this as the first level of your boundaries. And then you can, inside this subdomain, this sub-part of your domain, you can further divide it accordingly to your needs, but the idea is to have the boundary driven by the domain. So instead of following a tutorial approach that we see a lot online, that you group things by technology, so things that deal with the database, things that deal with validation, things that deal with with the interface, you don't do that at first, at least. You first group them by their context. So I'm grouping all the yellow things, different technologies, then all the blue things and all the green things, because they belong to different parts of the domain, to different subdomains. And this promotes autonomy, and autonomy is a great quality if you're thinking about evolving your project that also involves code, involves also autonomy for the teams that are taking care of this code. So this also favors the migration to microservices if you are intending to adopt this architecture. And with this, you have a more adherence between your development teams and your business teams. So they can communicate better because we are always dividing the code, following the same structure that the rest of the company is divided into. And next step is the final one, step number 4, is separate data by context. So also follow these kind of divisions, not only into your code, but also in your data. So, okay, you follow all the steps so far, and you have a modular application. It's very beautiful, but all the modules in your application uses access, writes and reads from the same database. The idea is actually to split this, as much as we have this illustration here of a city that you can see there's a more commercial part that has big buildings, but it's separated from like a countryside part that has smaller houses, some farms. So the idea is actually to keep following these divisions of purposes, of domains, also in the database when you're talking about data. So instead of doing this, you can split your database into 3 different other smaller databases here in this example. The idea is not necessarily to physically separate them into 3 different instances of databases, but you can follow some more lightweight strategies to divide this by using different table names in the same PostgreSQL, for example. And okay, this is good because with this, you avoid any kind of race condition, so you don't have people locking your reads, people that there's no relation to what you're doing, locking your reads. You also respect data ownership, so it becomes more clear who is the owner of the data and who is only consuming the data or using that data for other purposes, and also enables you to go to the next level that is more microservices driven, that you have a polyglot persistent, which means you can follow, you can adopt the most adequate database for that purposes. And in another module, you have another database choice. So it's more flexible in this sense. So what are the takeaways here? The stories that I told here, they translate basically to the strategies that I illustrated with some more architectural illustrations. So with that, I conclude my talk. I thank you very much. And if you liked what I talked here and you want to continue this conversation, you can write me an email. I'll be very, very glad. So thank you.
Thank you very much, João. So are there any questions? There is one.
Hi, I think the point 0, the first point you talk about, the problem can be to find when is the good timing to leave the monolithic version and switch to microservice. This can be, in my opinion, you have to define the right timing. That sometimes is very difficult.
Yes, I couldn't agree more. I mean, we are talking about microservices for about 10 years now. It's a mainstream term, or it's a hype term, but this time of abandon the monolith, it's still hard to decide. The idea with these strategies that I presented here today is actually that you could apply to your monolith, so you can gradually leave your monolith behind, and you can gradually migrate to microservices. So both architectures in a given point of time, they coexist in the same application. You have a monolith, but it's kind of being abandoned. Some new features might be extracted because you have boundaries, you have abstractions, you have data divided into the database or into different databases. And this allows you for extracting new microservices. So you have like a node monolith that still do some of the work that you need, but you also have some new microservices that have been easily extracted in the journey. So it's like a planet, your monolith, and some satellites that surround it that might be this new microservices.
We had another question over there, I don't remember. Some other question? No questions so far. So basically, you're saying that it's kind of splitting up your monolith over time, right? This is your approach.
Like scratching out functionality, but you have the architecture to support it. So it's not a pain a huge pain for you to extract functionality from your monolith into new microservices surrounding.
Especially when you have database and you said dividing the context, maybe you have one database with everything in it, so that's obviously taking probably a bit of time.
Yes, yes, yes.
Okay, thank you very much, João.
Thank you.
And see you in 5 minutes.
Thank you.
All right, welcome back. So our next speaker will take us on a tour on aggressive use of Git branching with automation for distributed cooperation. This is necessary because in large open source projects, contributors often have to wait for their submission being accepted, and this is, I guess, pretty annoying. So welcome Yuri Delia from Prusa Research and his talk about automating Git for development on large distributed teams. Welcome.
So I want to talk about the use of branches in Git, which is probably you are familiar with. So one of the reasons we use Git is because it's very easy to branch off. Essentially, it's the easy way for developers to share code, test stuff independently, and also merge back these changes. So if there are many people working together on the same project, the biggest hurdle is actually work on the same thing separately, then merge it back, and somehow handle this in a coherent manner. So one of the biggest features, perhaps, in Git is actually the ability to write history, which is initially was considered maybe a drawback, but it's so popular nowadays that it has become a tool in our favor. And one of the reasons why we want history rewriting is essentially avoid something like this. So this is actually from a popular project. It's the Prusa firmware that runs on the 3D printers. And I took this screenshot, I think it was from 3 years ago, or something like this, and it was actually the state of the repository as seen through TIG, which is one of the utilities you can show the repository status. And you can see at the same time how many branches have been worked on at the same time. And if you feel that this is a nightmare to work on it, because it is, so it's actually quite messy, and people would like to avoid getting to this state, because it's actually really hard to track down who is doing what. So you've probably seen this, and even GitHub now gives you the ability to choose how do you want to merge back your changes back to the main repository to avoid the mess. And there are essentially three ways which you can do this now. And there is the classical way by doing a merge, which is what everybody considers noisy history. So you get the mess because you get the merges and the parallel history. And then you have some intermediate, which is rebase and merge, where we fake the history by rewriting it to make it more linear. And then there is probably what I consider the destroy history feature, where you combine everything in a single commit to make it very nice and tidy, but you lose all your development history. So for those who are not familiar in how these work, the concept is like this. So you take so every dot is a commit. So you start from a merge branch, and then you start on a branch, which is B. And on a regular branch, you do some commits. The main branch might do some commits either, and then in the end, you merge a history, and you get a merge commit. With rebase, we fake the history so that at the moment of the rebase, we move all the commits to the tail of the main branch. So it looks more linear. And then when we do squash, we actually combine all of them and just get a single commit with the final feature. So depending on what you do, one or the other might make more sense. And there is a great debate on which one is best. So many times, a team has to decide what to do in which case. And we do something which is called a workflow. So we agree together that when we do something, we choose one strategy over the other. And there are many workflows. Some of these are very famous, some are less. But to give you an example of a popular workflow is that if you're working on a feature and you discover a bug, well, a good strategy is to split that bug into a separate branch so that we can test that the bug is fixed independently and then merge it back separately. And so if we do that, we actually simplify development because then we can guarantee that the bug has been fixed, and then we can test We can run the test without the new feature, and everything in general is simpler. But we do increase the number of branches that we need. And one problem, as in this bug and feature case, is that if you're fixing a bug that you discovered on your branch, is likely because you need that bug fix in order to continue working. But if you need to submit the bug fix as a separate branch, you introduce a dependency, so you become stuck. And that's exactly this case. So you start working on a feature, you discover the bug, you have a policy that says the bug needs to be fixed in a separate branch, so you do that. You create a new branch, which is based on the master branch, you fix it, then you submit, then you can go back to your feature, but then what do you do? So one strategy, which is pretty simple, is to merge the bug fix into the feature. And you get into something like this. So you fork off the main branch, you start working on feature. At some point, you have to fork off again from the same point, and you fix the feature in a separate branch. So you switch back to the feature, and you merge again your bug fix into your branch. And of course, it's never over in a single iteration. Usually, the bug needs more fixes, and the feature will also need more fixes. So you will get into a history which becomes tangled pretty fast. So why do we need to wait? So if you are in a workflow where you want to ensure that the bug is actually fixed, the problem is that you need to submit, and you might need a reviewer to approve your bug fix, or you need to run some tests that might take days, or you might be waiting for a developer which is in vacation. So it might actually take a long time. So you cannot pause your development just because you're waiting for the bug fix to be merged. And that's pretty obvious. So to give you one example, if you're working on a feature and you push it to a public repository, there is no guarantee that it's going to be merged. So to give a concrete example, I have some pull requests that I've submitted to for the repository I'm currently working on as a collaborator, and these have been pending now for 4 years, and they are still there. And I'm using, actually, these features. So what can we do about this? So if we use Git effectively, we can absolutely continue by merging and handling these branches together by hand. And we can actually create dependencies and relationships among these branches. So if we merge a bug fix into a feature, it's likely because there is a dependency. We need that bug fix into the feature in order to continue working. So if you do this often, you might need that this pattern keeps repeating and repeating all over again. So there's an opportunity for introducing some automation into that. So there is a tool that I wrote to overcome to this, which is actually not innovative. It's based on TopGit, which is an alternative that was existing for at least 10 years, I think, which allows you to declare just a very simple script, the relationships that you have between branches. So if you can create a branch, you can say, always rebase this branch on top of this, or always merge this branch into this other branch. And it does everything that you would normally do by hand, almost line by line. The only difference is that it only acts on it if there is a change in commit or content. So it will only merge a pull request and do the necessary work if that branch has changed. So to give you an example, let's imagine the case from before. You have these two branches, feature and bug fix, and you know that they are going to evolve, and you want to keep merging bug fix into feature. One example script using Git assembler would be to say merge, then you have the target branch, which is feature, and then the bug fix. And then Git assembly will essentially merge bug fix into feature every time feature is updated. It's very simple. So if you consider this as a lone example, you would say, OK, I can still do this by hand, and you definitely could. It gets more interesting, of course, if you have something different. So the classical case, if you're doing reviews, is that somebody will say, but the master branch has some extra changes, and these changes might be conflicting with your bug fix branch. So can you please rebase all your changes on top of master? And that's actually pretty common. And it's also one operation which is increasingly required when you're basing your workflow with rebases. So you will need to have to do this at some point or the other. So you go ahead and you rebase the bug fix branch into what I indicated here with bugfix2, which is the same branch, but now it's rebased on the latest commit from master. And of course, the problem is that now bugfix, you cannot merge bugfix into feature anymore because the commits are new, are rewritten, so they would conflict. So the classical scenario to fix this problem is to start rebasing feature on top of bugfix as well. So again, it's another form of dependency, it's the same stuff. Feature depends on bugfix, and bugfix is now on top of master. And you can see that we just rewrite also the commits from features on top of master. So we get into this sort of chain, and the idea in the end is to simplify the history, because once you rebase both of branches in the right order, you will get a nice and linear history. So what do you do that with Git assembler? Well, actually, you just write the two rules. I want to rebase bugfix on top of master, and I want to rebase feature on top of bugfix. And it will do this in the right order because it's going to do a topological sort of the dependencies and do them as required. So giving you the ability to simplify this workflow to the point where when you can have dozens of branches, you don't have to think about this anymore. So for example, I've been using this to actually manage my own fork of some projects, just giving a long list of, I want to base my work on top of the upstream repository and merge this pull request, this pull request, this pull request, this pull request. And if any of those are updated, I can see it in the status report. This has been changed and it need to be merged, or I can run the tool to actually recombine all the patches into something. So there are a couple of extra features that you can do with branches. Normally, it's just merge and rebase, as you would expect in Git. And there are two extra types of operations which are inherited from TopGit, which is stage and base, in which case we actually create a new branch every time we fork off. And this actually pays off when you want to create some testing branches which are a combination of something that doesn't exist. So for those features, actually reading the manual is very recommended. So I don't want to push my own tool for this. There are actually others which are going towards this sort of approach of managing branches as logical blocks that you can build upon. And one of the simplest tools is StGit, StGit, which is the oldest, which manages mostly a linear sequence of patches. Then there is TopGit, on which Git assembler has been inspired, heavily inspired from, which shares many similarities, but enforces to keep the history of all the changes. When I wrote Git assembler, I didn't want that. I just wanted the bare bone tools to implement anything on top of branches without enforcing anything. And ironically, there is another tool which has been emerged lately, which is called Git replay, which has been inspired by Git assembler. So there is even more choice for you to use from if you want. So why would I recommend Git assembler on top of the other? Well, it's up to you to decide, of course. But one important point for Git assembler is that it's completely stateless. So it doesn't keep track, or it needs to keep track of the history that you did on your repository. You can just write rules, and it will do exactly what you wrote. So if you are operating on the repository by hand, by creating your own branches or writing a commit by hand, you can always rerun Git assembler. It doesn't care. And that's the biggest difference compared to the other tools. And I hope this can help you in your management of a multitude of branches. That's it.
Thank you very much, Yuri. Are there any questions? Quick, we have half a minute. No questions so far, all Git experts here. One question there?
I personally love the linear history, and I wonder why don't you show the merge no fast forward? I find it best. It's strange that I do not see it there. So the history is linear, but you see the branch, the feature as a set of separate patches. Do you like this? Do you see any disadvantage or?
My personal opinion is that I wished everybody would use merge all the time, and we wouldn't need rebase at all. The fact that we actually need to rewrite history, to me, it's because there is some sort of general lack of better tooling. So if we had good tools to work with the history, I think we wouldn't need any other option. Rewriting history gets really annoying, for example, when you're working with other people which push branches online, and then they force push, which breaks all your dependency on your local side. And in that sense, I don't see a very big difference between fast forward and non-fast forward. It depends on the context. I think these choices depend a lot on the team that you're working with and your global preferences. In these cases, I would follow what everybody else does. And this is also why I brought Git Assembler, because the other tools were forcing me to keep a certain style of history. For example, TopGit requires you to keep the history, and if somebody else doesn't use TopGit, would find a load of branches which are meaningless for them. In this case, I can write the rules. For example, to choose fast forward or non-fast forward, it's an option that you can choose in Git Assembler, for example. But it's up to you if you want to use it or not. You can ask your colleagues what do they want in that case. Personally, I don't have a strong preference for one or the other. It really depends on the team.
Okay, thank you very much. That's it for now. 3 minutes left, so see you at the next talk. Thank you, Yuri. right, so we're back here. Our next speaker is Andrea Alfonsi from University of Bologna, and he will explain how Kubernetes can help you quickly and automatically test and deploy new services in the world of IoT. So welcome, Andrea.
Yeah, thank you. Everyone can hear me if I speak this loud? Okay. So in this presentation, I want to convince you that Kubernetes is born as a server tool, but we can use its features also in IoT world. So I'm going to start first defining some concept we are going to use to have the same wavelength when speaking. And then I'll try to expose all the features it has that help us in the IoT world. So the first topic I want to discuss is what I mean for the IoT. Because looking online, we can find very different opinions about the IoT world. So IoT is usually called also edge computing or simply edge. And in this presentation, I consider IoT device every device that has at least 4 GB of RAM, 20 GB of RAM, and 2 cores. Because they are fundamental for the master node of the Kubernetes cluster. An easy rule to remember what are the minimum requirements for a device is try to run Linux, and if it runs, almost certainly it's a device that can run in IoT. So Kubernetes, as we said, is born for the server, for server cluster. So that have a lot of space, CPU power, and memory. So how we can bring such a complex and huge ecosystem into small devices, we have to rely on some alternatives that are based on Kubernetes and strip away some components to be more lightweight and require less performance. So some examples are Minikube, Micro K8s, and K3s, which are the most famous. But if you search online, you can find tons of alternatives with pros and cons. Some use more RAM, some use more CPU, and so on. So why we should care about computing in the edge when our infrastructure can run on the cloud nowadays with all our existing tools? We care about a new technology when this can bring value to our business or at least make simpler to manage the whole infrastructure. Moreover, if we check online the opinion of lots of agencies, like the McKinsey Consulting, we always see that the IoT world is going to explode in the next year, and in many sectors, from vehicles to robotics to smart house and so on, with a market that grows up to 200 billion. So this market cannot be ignored anymore, and we need some tools that help us go inside these topics. So as you can see, the IT infrastructure is not based only on sensors and small devices. It goes from the devices up to the server, through all the gateways, routers, and so on. So when I, at the start, said that all devices have minimum requirements, I didn't mean only the sensor or the mobile devices, but I mean all the components up to the server. So what is the most important topic we are going to cover here is the scalability. So the scalability is defined, as you can read, as the capacity of a system to grow or reduce depending on the workflow, on the work required. because the IoT world is characterized by lots of data transition and devices that can connect and disconnect, the quantity of computation we require fluctuates in very huge amplitude. So how can we scale this, our service? We have two ways. The first is to run the command you can see. So C is a normal Kubernetes command with the prefix micro-KSS if you use micro-KSS, or another prefix if you use another service. Or the other way is to use the automatic auto-scaling service offered by Kubernetes, which is also bring to every package we see before, like micro-KSS, and allows us to scale automatically based on some metrics, like CPU or RAM or extra metrics we can give to the cluster. So once we have all the service running, we need to find a way to split the work based on the devices who can handle the best the request. Kubernetes offered automatically some way to manage the request through the kube proxy component, which is also available in all the distribution of the Kubernetes stripped version. And he offers us different ways, like round robin or ring hash, which are two different strategies to reroute the request to different devices. Why this is important? Because we don't, if a device crashes, we may be sure that another device can take its place. And this capacity of a system is called high availability. It may happen that a device crashes, so it cannot run what it was running before it fails. And this can cause some problem because I'm missing a component where everything's worth tightly bounded can cause the fall of the whole infrastructure. So high availability is another topic that Kubernetes can help us take care automatically of, because it was already thought by Google at the beginning to be sure its service never fails. Another important aspect of high availability is the fact that a service that share data needed to share constantly data with server and other devices. But keeping a device constantly connected to the network exposes the devices to lots of attacks. So Kubernetes automatically offers us some security features, and also apart from the whole containerization technology that almost everyone's used nowadays. These features are not automatically included in all the stripped version. In fact, I put as example the RBC package, role-based access, as an authorization technique that must be enabled through the command before using this package. This allows the micro-KS service to run smoothly without using this service unless it is explicitly required. So, in the last year, also the paradigm of IoT has changed really heavily. In fact, when the IoT world was born, the devices were developed and designed with the purpose of remain stable when shipped outside of the factory. While in the last year, the paradigm has changed, and nowadays the devices go through a process of evolution and updates. So we must be sure that all the updates are correctly installed by each devices, or even if some devices are offline for a long period of time and then reconnects back, they must download the update and install in the best way possible. So Kubernetes for IoT can help to solve this problem in 3 different ways. The first, it supports over-the-air updates. So we don't require to go directly to each devices, but we can simply run a command and all the devices will automatically update. It is even possible to connect the cluster to a GitHub or GitLab repository and automatically update with a push, but this is much above the scope of this presentation, so I cannot cover it. Another way to update the devices is the rolling update strategy. How this works. The Kubernetes creates 2 containers, one with the old version and one with the new version. And when he is sure that the new version runs smoothly, he kills the old version. So from the outside, the update is nearly invisible because the service was always available. But under the hood, the service is changed according to our command. And finally, when an update fails for any reason, Kubernetes can automatically roll back on the previous version of the update. So the device is still running what we are expecting it to run. If you have some minutes, I ask you to please follow this link. There is a Google form to compile, to give me some hint to make a presentation better. And no data is collected on this form. Thank you very much.
Thank you very much, Andrea. Are there any questions from the audience? No questions so far? Okay, so thank you, Andrea, again, and we see each other in about 7 minutes. Welcome our next speaker, Eduardo Guerra from the Free University of Bolzano, with his talk, Pitfalls and Mistakes when Dealing with Non-Functional Requirements. Welcome, Eduardo.
Hello, everyone. Thank you for being here. Today, we're going to talk about non-functional requirements, which kind of also have some other names. One that it's more used today is like quality attributes or quality attributes requirements. The one that I kind of like, it's this extra functional requirements. Some people don't like this known function. I say, oh, saying no to the function, kind of weird. So we have these other names, but basically what we are talking here is about the requirements that is more about the how than the what, right? So usually like what the system can do kind of describe the functionalities, and these kind of requirements show a little bit on how these things should be done in terms of many talks we have here today was about some non-functional requirement, like talking about scalability, security, performance. So we are going to talk about these kind of requirements, but unfortunately they are like the ugly duck, right? Usually it's not the client's favorite, right? They want to see his software kind of doing new stuff, right? When you say, okay, what do you prefer, to have a new screen or maybe that security thing on the server that nobody will see, right? So maybe it's protecting the system, but maybe from his vision, it's not doing anything different or being more flexible or being more scalable, right? So usually these kind of requirements are a little bit of the ugly duck that everybody, okay, yeah, it's here, but it's a kind of a duck we need, right? So in the end, it will be the duck that will save the day, because without having these requirements well-defined, we don't know what to do in our software architecture, right? We need this. And in this talk, we are going to talk about some mistakes, right? Some anti-patterns on how to things people do wrong when dealing, especially with this kind of requirement, right? And this is not something I just came up. It's based on some survey we did with a lot of professionals, and also in this paper about the anti-patterns, okay, blah, 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 a lot of text, but what we are going to do here is something a little bit more fun, that the format of the presentation will be, I'm going to show you a comic strip, original one, right, that will show a little bit this problem, and then we are going to take a lesson from it, right? So let's start. So friendly to whom? Right, so imagine now the client kind of look at this screen like full of stuff all over the place, and he said, oh, that was not this requirement that clearly say that the interface should be user-friendly, and then the developer look at the interface. It's kind of pretty friendly to me, right? So then I see a lot of this stuff, like, the system needs to be fast. It needs to be flexible. But how fast? How flexible, right? So it's pretty common to see this kind of thing. And the first lesson is to define testable requirement. I think the word testable is kind of pretty much important here, and that not require any kind of subjective interpretation, right? Because what is friendly to someone might not be to the other. Okay, good. Let's go to our second. Covering everything. Okay, so that's the someone is specifying the requirements and put there something like, oh, there should be a password protecting all the entrances, right? And then when this requirement is implemented, he's kind of surprised, right? In a moment, let's say, that he can have let's say the nature called, right? And he needed, and then he faced this unexpected block, right? So what is the idea here, right? It's when people define this kind of requirement without defining where these requirements are valid, right? So kind of, okay, that's this performance requirement. Okay, but it is valid for the whole system, for that report that is generated once a year. I do need this same requirement as for, I don't know, submitting this form, right? So sometimes we just define these requirements and we don't define the scope, right? So they cannot be so wide. It's important to define where these requirements should be applied. So the second lesson is to define to which part of the system a given requirements apply, because it's not to everything. The old post-it. Now our characters are post-its being planned, right? So that's the new requirement getting into the backlog, like, oh, it's nice to find another non-functional requirement here, right? I hope we can be implemented together like good friends in the next sprint. However, the other one, you can see it's even kind of old, right? So, I will not count on that. I'm here since the beginning of the project, right? I know this wall for a long, long time, right? So, and that's the next thing, because sometimes the requirements are defined, but they, let's say, suffer some kind of starvation, right? So they are there, but they are never prioritized and put to be developed, right? So then why having the requirement there if it's not going to be implemented, right? So I see, for example, refactorings, like it's like the guys that became old, right? So when I was here in the backlog, everything was grass, right? So are the refactorings there in the backlog? Right, so there are some stuff that are never prioritized. So this third lesson is try to consider including tasks related to the quality attributes in the plan in the every iteration. Maybe not everything, but tries to have at least a little bit at a time to make the architecture evolve and not just evolve from the functional point of view. Okay. Precious requirements. Now we changed the artist, and who did this drawings? It's my 13-year-old daughter, better than the other ones, in my opinion, at least, right? So we have then the architect trying to explain to the client, like, oh, we need to evaluate which requirements are important for your system, right? Doing some trade-offs between security, performance, adaptability, blah, 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 and then the client look at him and just say, my precious requirements, we want them all, right? So he don't want to know, he wants everything. He don't care about doing trade-offs, right? So, and that's one of the big mistakes, because sometimes implementing these can be too expensive, and maybe when you try to implement a requirement that is not important, you end up hurting another one that would be much more important. So thinking about these trade-offs is our fourth lesson, right? Consider the costs and trade-offs between these quality attributes when defining them. The sacred number, right? So imagine now talking to the clients, in how much time should this report be generated? Right there in the beginning of the project, he didn't know, right? So he said, I think 3 seconds is fine. then you cut for some months later, and then now these 3 seconds is something sacred, like, oh, it's impossible to generate this in 3 seconds, and oh, the client asked, he should have a reason, right? So people sometimes just get these numbers, and I already see, in the end, maybe they managed to implement this, but after a lot of effort and cost, right? And maybe he don't actually need these 3 seconds. Maybe something else would be even good. So the 5th lesson is to create some feedback cycle, so then the developers can question some of these requirements and maybe discuss these trade-offs, not only in the beginning of the project, but also more in the middle of the project to see what is the best approach. The most popular method, I think this one maybe you already see someone using, right? So when asked, okay, how does your team define performance requirements? And then she answered like, we use the WUC method. Anyone knows this method? I think you know. It's when user complains, right? So when the user complains, it's kind of, the user did not say anything. Let's just do it, and when it complains, we kind of figure it out, right? So the 6th lesson is like, sometimes the client is not technical. He will not ask for this kind of requirement. So it's kind of your job to understand what it's its needs and define and work in the system that has these requirements implemented, right? So this is our 6th lesson. We have 2 more. Don't worry. The general storage, right? So on this one, you see that she has like this security requirement. So how do we handle this security requirement? What we do with that? So you can put there together with this other ugly ducks requirements. And then when she get there, she see, okay, maybe this is not the best place for keeping all of these different stuff, right? Okay, the usability is right, but the scalability seems not the best way that I handle usability, or this adaptability is kind of not staying there. Performance is a little bit tight, right? So the lesson here is that I see people try to, let's create a process and let's treat all of these kind of requirements the same way. But they are very different among themselves, right? So the way you handle the security in your team might be completely different on how you handle performance, on how you handle scalability, right? And that includes how you define, how you test, how you handle, how you validate these requirements. So treat each type of these quality attributes in the most suitable way. Don't try to come up with this standard way that will not fit them all. Maybe when you try to use a way that's suitable for one for another, that will not work. Okay, so the last one, the pedestrian requirement. What is that, right? So, okay, sure, our app needs to be compatible with all of these platforms. And then the other one asks, it was here when I came here, like some caveman leave this requirement for us, and then we just trust it, right? So sometimes, I don't know if you already see this, but I see a bunch of times when you ask, why you have this requirement? People don't have an idea. They don't know where this came from. It came from the beginning and nobody ever reviewed it, right? And sometimes you end up with things that don't make sense anymore, right? So, and then the 8th lesson is like, consider that these quality attributes also changes, right? Today we have systems that have many years of life. It's impossible to predict today's requirements, I don't know, 20 years ago, right? So these requirements also change, right? So they also should be reviewed to see, okay, this maybe when the system started makes sense, but maybe don't make sense anymore. So always review and see what still makes sense for you or not. So I finish with this sentence: change is inevitable. So yes, the requirements will change, right? Even the non-functional, the quality attribute ones, but growing, right? So using these to make a better system, then it's optional, right? It's up to you.
Perfect on time. Thank you very much. So
thank you.
It's fascinating to see all those the requirements. Thank you very much at all. So we will continue in about 4.5 minutes at the next talk at 5 o'clock sharp. Okay, welcome back to the developers track. So our next speech will be from Daniele Fontani and Daniele Ciulli from Sintra Consulting. And with them, we will discover the low-code framework that accelerates app development, CrewedIt, so an open source framework that makes developers autonomous. Welcome to you both. The floor is yours.
Thank you everybody. We will talk today about CrewedIt. That's a micro framework for fast shipping application. Before introducing the framework itself, it's important to explain why we created a framework and why we share our framework as an open source application with all of you. To do that, we have to explain what it means developing a web application in 2033. We started from a monolith that was something very easy because all the things was put together in a single application. Now, perhaps we have a lot of components. So we have a single page application from one side. We have a lot of microservices that are orchestrated by an API gateway. We have background jobs. We have message queue. We have many kind of different database. All one of this block require different skill, different people that have to work together in different teams. That's very huge number of people, huge number of different requirements, have a very good practice for getting some benefits, of course, because we can take the best of breed for all one of the components. We can work with multiple teams that work in parallel. And moreover, we can get better performance from this architecture. Of course, we have a lot of good things, but we also have some issues because we need to have a lot of people involved. We have to work with multiple teams, so cost of communication explodes, and a single person no more can do the job. So it's not always easy to manage a situation where there are some problems. These features impacted a lot low-budget projects that are frequent on small companies or startups. And sometimes we need some more quick and dirty, so some way for allowing a small team with few competencies, especially few backend and sysadmin competencies, to be autonomous and able to deliver a whole application without involving a lot of people, a lot of teams inside a single project. Well, the question is this possible in 2023 with all these architectures to develop a web application with easy? Of course, yes, we can with CrewedIt. That's the framework that we are going to present today.
Hi. Yes, what is CrewedIt? CrewedIt is a low-code, lightweight JavaScript library that can be used to build fast shipping application, and it is easy to implement in existing Node.js project to make some changes on the project without needing any sysadmin knowledge or to edit your Docker file to change everything on your system. CrewedIt can be used to build fast a multi-tenant Node.js application, and can be used in an existing Node project with a Mongo Atlas, a MongoDB database, quindi a document-based database, to mutate your data easily and fast, and can be used with a project for form retrieval in a front-end first project, so it can be used to retrieve data from a landing page for a promotion, something like that. But how? CrewedIt, it's a JavaScript framework that, once configured in the most basic configuration, can deploy a Node.js REST-compliant API using Node.js and a Mongo database. It can do many more. Can do more than a simple CRUD interface with a database. Can create custom endpoint, server-side validation, data mutation, and hooks on events. So it can be used for many, many other things. Let's explore all these features. So you can see how simple is that to create an application with Crudit. First of all, the basic configuration. This is the basic configuration for a MongoDB with Crudit application that exposes a REST-compliant API for writing, reading, updating, and deleting the file on a Mongo Atlas database. So you get a RESTful API, and it's simple as installing a Node package on your on a Node project, and configure Crudit with a database URL. You can also create custom endpoints. Crudit, in the default configuration, has a single database for each user, and the collection where the data is stored is based on the path, then the call is made. So if you made a post request on the address endpoint, it will be save your data in the address collection on the database with your username. To create a custom authentication, you can create a custom endpoint. So with this instruction, you create a custom endpoint, in this case, on the endpoint publish, with a post request that needs to be authenticated. That's the flag true. You can handle the request with your custom application, and this can be used to create many kind of custom API, or can be used to create your custom authentication. Crudit supports server-side validation. So you can create some entities. The entities use validator.js syntax to validate your data before they are written on the database. So you can be sure that your data is clean, that there are the constraints on the structure of your data. You can also add some hooks to events on the database. So you can add an hook on before save. As you can see, on before save, you can add a log that saves the date and the collection, database, and user info. So you can create just as easily a log for your application. These events are synchronous, so you can block the writing on your application with a before save hook. Let's say you want to validate your data with an external service. You can do this with an hook and a call to your external service, your external API. The mutation. During the life cycle of your application, sometimes the data needs to be mutated on the existing data on your application. Let's say you want to add a new attribute to your user object, and then you need to make the existing user having that attribute with a default value. You can mutate with a mutation the data already existing in your database. You can do it with registering a mutation. You register a mutation on everything. You can use this attribute, this parameter, to define a regex. In this case, I use the star as select on all to mutate your data. And the regex is on the name of the database. Then you can mutate on, and then you can apply a single mutation on a single database, on a single database, and on a single mutation on a single database. You can apply a single mutation on every database that respects this other regex. or this other database name. And the flag is for keeping the mutation run even if there are errors on some execution. And you can apply all to apply every mutation registered on every database in your system. Obviously, if you apply all, the requirement for a database to have a mutation applied is on the mutation definition. What about DevOps? If you want to make a simple CRUDit-based application, you don't need DevOps because you can use it on serverless platform. CRUDit is working on every Node.js runtimes, so you can use on Cloud Function, AWS Lambda, Edge Function from Vercel. You can choose your favorite vendor and can be used across every service. And what is for? It's for a model full-stack JavaScript application. I think about Next, Nuxt, Svelte, that need a database connection and want to make it very easy, very straightforward. In general, to MongoDB, we add Node.js applications, existing or brand new. To any project that doesn't need complex infrastructure and are written mostly in JavaScript, I see a form retrieval information from a marketing campaign that needs to simply populate the data from a form. Explorative or amateur project, because with this requirement can be deployed easily on the free tiers, but then it depends on the success your amateur explorative project has, but it can stay in the free tiers. We need something else, it's not for everyone. If your application is as a focus on multimedia, CRUDit is not for you because it doesn't support at the moment assets. If you need strong relational data, if you have a high business logic complexity, or if you need some interface for your backend to graphical interface for backend, or if you need separation to business logic from data. What do we want to add? This is the wish list for new features that we want to add to CRUDit. We are open for suggestion. We want to create an import from YAML and JSON files, so you can create your YAML, your JSON, and deploy CRUDit more easily and in a faster way. Support for media asset without creating a custom endpoints, so you can put your media asset in a bucket, such as Amazon S3. And we are open for suggestion and GitHub stars. So, thank you. This was CRUDit.
Thank you very much, Daniele. So, are there any questions from the audience? No questions so far? Okay, so thank you very much for your speech, and we will see each other in 5 minutes here. Thanks.
voce normale come questa, ok, va bene. Sì, mi hanno già spiegato, c'è il timer, e gioco con questo, ok.
Okay, so welcome back. Our next speaker is Luca Basile from Entando. And in Entando, they created an open source application composition platform. So fueling the capability economy through FOSS contributions and empowering community-driven innovation, the Entando Marketplace. Welcome, Luca.
Hi, everybody. Thanks for coming and for attending to this presentation about the Entando Marketplace. A few words of introduction. I am Luca Basile. I work as an architect, as the technical lead in Entando. I follow our customer and give some suggestions about the architecture and the implementation of their project on our platform. Entando is a company that works on an application composition platform, as told before, and basically is a new way to build web applications. By this we mean that you want to build an application starting always from scratch. Basically you can rely on building blocks that you have already built before, or that you can import from third parties that will prepare for you functional blocks, building blocks. We'll cover these with more detail in the next slides. So a few words about the company. We basically are a company that is a startup, has grown in the last 10 years, more or less, and recently has been really focused about the application composition topic. Gartner has recognized this company as one of the sample vendors of this new market that is the application composition. And as you can see, we already have some sort of market there because we have customers mainly in the public sector in Italy, but we have customers in the US as well. Elevance is a great insurance and is using Entando to build their web solutions. What is a composable application? It's a very complex topic, so I asked some suggestions to ChatGPT, and he provided a very well-defined, very detailed definition. Basically, composable applications are modular software systems that enable flexible assembly, integration, and customization of independent components to meet specific business needs. These components are designed for usability, interoperability, and scalability, promoting rapid development and adaptability. It's a very good definition, to be honest. I couldn't come with a better one, so it's there. And we have a lot of stuff here that we want to cover, and I'll try to give you some detail before focusing on the topic of the presentation. So, basically, how is built an application like this? What is inside an application that is composable? Basically, you have software. What a surprise. We have software that is built using some of the principles that you already have met in distributed architectures. Basically, you have microservices for the most. And this software is intended to be something that you can deploy in an independent way and can be assembled in an orchestrated way. These are two very important concepts, because it's not that you have a software that is deployed always in the same way. It depends on how you assemble the software. And what is important that all the building blocks can be deployed in an independent way. This is a concept that seems quite similar to the Docker one, but we have a deeper aspect here, because each of these components, when inserted in some runtime that is able to let the RAM and serve your user, basically will fulfill a lot of requirements that will be technically done in an automatic way if your environment allows that. And apart from the informations that are mostly exposed as APIs generally, you have a lot of channels that you can serve. And all these building blocks should have the means to satisfy the needs of all the channels. So you can have here a representation of multiple channels with web, mobile, IoT, whatever. Once you have the software, the information, you can empower this information to serve whatever you like to do. And what is important that you can modify the global software by recomposition. In each of these building blocks, as mentioned, you can find basically technology that you already know. And this is very important because in this kind of component, you can put whatever technology you want. Because this kind of architecture is built in order to give you the chance to use any technology that can be Dockerized. And this is made by isolating these components and using high-level interfaces in order to let these components communicate with each other. Basically, you have APIs and you have events. It's not something new, but what is important is the freedom that you gain and the aspect of the combining of all these elements together in the way you want. Okay, I mean, I think that this slide was to skip, but okay. So if we put everything together in a platform that will allow everything to run smoothly, basically you will have all these components, and as you can see, these components are not serving just one web application. Depending on the context, you can have micro frontends dedicated to specific use cases. And so when you deploy a PBC, you will have a lot of micro frontends dedicated to specific use cases. And enabling these components to run in your platform, you will be able to compose the final user experience. It's important that you have a lot of complexity here. you have all these Dockerized mini applications that need to work in a decoupled but very cohesive way, just to follow the microservices motto. And you have a lot of complexity you want to address. And if you have a platform that allows you to do that, you can have a lot of leverage on the work that you can just delegate to the platform. So all the lower side here about orchestration, integration, development, operations should be delegated to the platform, the runtime. And we can understand that we want to pick all of the components from some sort of repository, a marketplace. We'll cover this deeper now, but just let me say that this complexity is as well reflected in the actors that you need to have on your platform. Basically, you need to have a lot of people working on that. And for each people, you need to have a simplification of this complex work. And a platform should provide this. Basically, as you can see, you have people that are dedicated to the creation of your mini application, but even people that are in charge of putting them together and to handle the life cycle of this web application. And by this, you need to refer always to this central element, again, the catalog, the marketplace. If you want to give a full layeration of this sort of application, we have something like this. As you just layered all different kind of operations. But this is the flow you should follow. And basically, so you have someone that needs to develop an application, and they should start a process of an analysis and defining all these components. Once you have a mini application defined, you can put them inside your marketplace. And when the task of assembling them is going to take place, you will need to find these elements. You need to discover these elements. And you need a lot of detail on that. It's not easy, because all of these mini applications rely on something, rely on integration, can rely on a message broker, can rely on some sort of specific database. And you need to know these, because you may need to provide the means to make them available, because if you are not following the idea by the letter, you can still have some requirement to have this run. So the flow obviously will end with the application running in the end. But what is all of this, and how we implemented this in Entando? Basically, we have tried to cover all these aspects. As you can see, we have a dedicated aspect of this platform for all the actors I mentioned before: creators, curators, composer, and the end consumers. And all of this is handled in an automated way. Basically, let's go to here. We have an application that is built with these elements. In our version of the components are these elements, these packaged business capabilities. Inside of this, we will find exactly the tech stacks that I mentioned before. So you will have micro front-end and microservice. It's not important in technology. Whatever runs in Docker, run on the platform, because we have these artifacts that we have built on top of our Kubernetes architecture. And these are basically custom entities that we define inside of Kubernetes. And basically, we define all the means to make this running with a click. This is a very powerful tool that will allow you to install these, and ideally, once installed, this is running and serving your users. All the aspects have a dedicated API, and let me just focus on the marketplace. I say that this is probably the most central pillar of all the experience on this kind of architecture, because all the actors will have some side interaction with this element. We have elements for building, we have code generators, we have CLI for the operations, but in the end, everything will still have some point of convergence in this element. What is our marketplace? It's basically a UI where the curators, the people that are in charge to curate the life cycle of the PBCs, because they can publish PBCs, edit, analyze, and basically do all that is needed to take care of the life cycle of this application. It's very important that you understand that you can even start from something that is in the marketplace to customize a new version of the PBC. So you have all the freedom that you need. We have added to this element a lot of features. PBC discovery, as mentioned, clear requirements. You can take the source code of the PBCs, and we have role-based access, because you can even want to hide some of the PBC to some user. You don't want something to be public to everyone, maybe. Next versions will have enhanced PBC discovery with a lot of information of the communication, of the events, and meta informations that are now partially available. We are adding image scanning for security check, and in the end, we are adding a monetization flow. Basically, you can publish PBC on a market like this, and you can monetize your work. If you are not bound to just one hub, one marketplace, you can add, connect your platform to multiple elements like this. You can have our public hub, our public marketplace, but you can even connect your instance to different hubs. So you can pick up PBC to any source that you have available. This is just a structure of the complexity we have PBC even to customize our platform. It's not important for the developers, or maybe it's very important for the architects. You can collaborate with us. You can contribute to growing our public hub, following our tutorials, learning how to build a PBC is very easy. It's not very complex. It's just a matter of follow a few conventions. And you can so contribute to the community. These are our contacts, and I hope that you will try or you will enjoy to trying this new technology. Thank you.
Thank you very much. Are there any questions from the audience? Yeah, there's one. Can we have a microphone? Thank you.
I will just, if I well understood, then the whole thing runs on microservices. So like on Kubernetes, basically, you have all your Docker and images, and then you get the images that you need, and then they would, and in the end, run on Kubernetes, or it's another kind of platform.
It's a Kubernetes-based architecture, as I told. And basically, what happens is that starting from the development flow, you build an application on maybe your local machine, and you can build microservices and microfrontend, maybe. Or you can delegate the microfrontend to another team working on microservices. But what happens when the code is done is that basically you use a tool that is in the platform, our CLI, that will create that artifact I mentioned before, this bundle. The bundle is more or less a Docker image in the end, but it contains microfrontends and microservices, all that are needed for the PBC. When you publish the PBC in the market, basically you make this available for installation inside the platform. And when you decide to install the PBC inside your platform, all the Docker images that are in this hierarchy of images basically is deployed inside a Kubernetes cluster, is made automatically accessible through an ingress, or you can even customize this aspect. The ingress, we have an API if needed, for you would just publish APIs, and you don't want microfrontends, for example. But in the end, everything comes together, even in terms of security, because our operator will talk with our IDP, that is Keycloak, and we also provide all the security aspects. All the roles, the groups, all the directs in your security domain will be addressed automatically by the platform. So it's based on Docker images, but there is a lot of work under the hood behind the scenes that happens in an automatic way. Basically, who develops this kind of platform is not required to know any knowledge of Kubernetes, any knowledge of Docker, apart of docking or writing a Docker file. But apart of that, everything is automated. And in the end, you will have the ability on a UI that is basically like a CMS to build together the UI. And in the end, when you do this, you enable microservices as well. So everything comes together in an automated way, as I told.
Okay, thank you very much, Luca. So we have 2 minutes left for the next speaker, and see you soon. So, the next question is, what makes open source projects successful? So, and how to add external people to an open source project? Tommaso Bailetti from Netesis will answer the question how to ease contribution and management of your next big idea and improving developer experience in open source projects. Welcome.
Thank you. Okay, hello everyone. My name is Tommaso Bailetti. I'm a developer at Netesis, as you've heard, and I'm a student at University of Bologna. Why I'm here is for this company. Who is Netesis? Netesis is an open source company that develops NetServer. NetServer, I'll let you browse what actually it does. However, when I got introduced to it, I found some hiccups on the onboarding processes and many of the processes we have internally. Before that, we have an amazing international community. So you can just browse it and join us if you want. You will find the latest alpha and betas of the software, many people that are actually willing to contribute to us. However, even if you have an international community, we don't actually receive meaningful contributions to the project. I mean, don't get me wrong, we have people that notify us about bugs, about documentation hiccups, and so on, but we don't actually have contributors to the code. Easy to say that, but how hard it is to contribute? When I got introduced to the code base, I found some things that might need some fixing. Nobody knew in the company, so I dumped some digging into the code base. And everything is kind of blurry. In the recent projects, things are way better. We got documentation for developers, we got documentation for everything. However, some projects actually don't even have readmes, or you don't know what they are for. So, the first step I think our company is going to make, and this is a list, is improving our documentation. It's hard to say, but the main problem about documentation is writing it, right? Everyone does not want to write documentation, maybe at all. However, in the recent years, or even in the recent, like, 6 months, 8 months, we got a new helpers who help us. They're not perfect. We will find some hiccups and hallucinations about how AI can produce documentation. However, it's a fast way to produce documentation for the end user. It just doesn't need to be perfect. The next step of documentation is actually something that is our own issue. Why do people ask always the same questions? Because we are probably the problem of our documentation. It's sad, but it's a fact. We tend to forget about things or give things like a common knowledge base. However, it's not always the case. A good solution is to give the documentation to someone else to actually browse and understand, maybe, reproduce the code or the scripts that need to be run to run certain programs, and so on. This is an honorable mention because this actually happens quite a lot, because we have documentation, but it's outdated, and this is probably the message you always get when someone is not up to date. A screaming message, in the billboard or something like that, or in the messages. This is one of the most difficult ones, because if someone sees this, if someone in the community wants to, join, or someone internally wants to contribute to the project, it finds itself very difficult. For an external dev, you are gonna have this kind of situation. They're gonna go somewhere else. Easy as that. Okay, documentation aside, we have a few more topics about how we can improve the projects, every project. How can we reduce the time to code? And we got a big answer. Actually, I'm gonna off topic with this, off-road with this. If you've seen the Stack Overflow survey results that came like a few months ago, one of the tools that was mostly voted as the must-know was actually containers. And we're gonna go through that. Because from 0 to hero, so from knowing the project at all to code, it's not always that easy. You need to install, external dependencies. If yes, how many? Is Varia the right architecture, or it is supported by your distribution? It's too time-consuming. One of the solutions, as I said before, is containers. We will see, and it's already happening in most of the projects, that a single container can ease the development of everything that we do, because doing so, you have a single point of truth. It's easier for us to test all the things, have everything around it, and go forth with the same process, with the same container and the same version of the software around it. However, they are not all. Sometimes you need something else. You need something more powerful or more complex than that. You need a kernel extension or whatever. There are quite alternatives. They are not perfect, but most of them is running around building images and VMs, full VMs. One of them can build your own ISO, not the most easy task. However, some of the tool around, like Vagrant, for example, is one of the many, allows you to take a base and just run some scripts on it, just to get a kind of an idea of how the development process and the final development environment can be. It shouldn't be perfect, but it must give the idea. One of the things, I think is the most important one, and my colleagues in the room already know that because I always say this, we must define the processes around our projects. This is something that you must do every time. Write them down, write a schema of it, whatever. I don't even care. But you need to define the processes. They come in every shape and form, and they are, the style of the code. You run Python in this project. What the style of the code should be. You run check style because you run JS or Java. You need to find the style and the linting, and you go on, and you find that contribution, after you define this connector, it's way easier in the long term. Not only this, you can define and actually write down, it's something that you should do, how to contribute to the project, how to build the image or whatever you want to build, how to tag a new release, because you're gonna eventually have someone else take this project from you. And otherwise, if you don't want to explain everything, if you don't want to tell people that want to contribute to your project everything, you can then just automate it. Matteo this morning already talked about how important and how unforeseeable can be the processes and the pipelines and automations. However, in these kind of cases, when you have a pull request that comes right up, sometimes less communication is more communication. Let the tools speak for you. It saves way more time than you think. This I'm going to talk about a case of study. Because I watched the code and I went around the web, and this is a framework that I found very familiar with it because I worked on it many, many times. Which is Laravel, which is a PHP framework, and many of us just don't like PHP. The general vibe, it is what it is. However, they do the very things that run around PHP very, very well. Starting from documentation. Documentation is outstanding. From the first steps, they guide you all, and they made you reach even the API documentation, the PHP doc documentation, if you want to. But they give you the commands to do the thing, they run the command scripts, or they give you examples of what you can actually do with the code, in this case, the framework. They give you full-fledged virtualization solutions, because since it's PHP, running a LAMP server is not an easy task, especially if you have some versions that are not, the latest ones. They gave you everything, from Docker to Homestead. In this case, it's a Vagrant image. Easy as that. You need to ease and reduce as much as possible the time to code. This will help you receive contributions and interest on the project. We do even the last thing that I said, define processes. In this case, they defined, well, I think this is a bit overkill, a regular Markdown file might work just fine. The contribution guide, how to contribute, what's the style of the project, where do we want to go? There's a few things that people most likely want to hear when they browse your code in the first time. And that was all I had to say for today. This was how we are going to improve the projects in our repository with a few solutions. And we showed just a few problems, but probably most of the repository that run locally or by a single person have. Thank you.
Thank you very much. Are there any questions from the audience? There is a question. Can we have a microphone? And ask you please to stand up. Thank you.
Thank you for the talk, very interesting. I don't know if to the degree of the last example you showed, but I have seen several repositories that do give you some hints, more than a README, on how to use them.
Yeah.
I was wondering if you had some statistics or some idea of how many, let's say, GitHub, how many projects are there that follow some good guidelines, and how many are there that don't follow anything at all, that is just code, and if that can be correlated, I'm thinking of studies, to the amount of contributions that these codes can have.
Yeah, as you can see, this is a very important part. Not always the way you can allow contribution helps with your project. It's most about interest and other things around it. But many of the projects I've seen, and we currently use actually inside many of the software inside, you know, around the company, runs, I don't know, on Go, for an example. And the only thing that Go people gives you most of the time is the Go doc, which is hard to process at first. You know, it's very powerful because you write the code, it basically gives you an HTML page you can browse easily. However, it's hard to get to know to get around the process if you don't know what you're doing. This is the only issue I'm actually addressing right now. So it's hard for starters. After that, if you get the API documentation, it's way faster for someone who knows exactly what it's doing. At the moment, I don't actually have some statistic on it. I've just browsed around the code of our code base and, you know, compared to the major things that run around, like, you know, the Python documentation, for example. You know, not only the language, but all the project that comes around Python. And I've seen some connections between the mentality of the programming language. Like Python people tend to do things in a way, PHP tend to do things in another way, Java are way out of the league, do something else entirely. So they're not there, but if you look around it, there are not many projects that stand out, or they tend to diverge from the general idea of the language. I mentioned Python. Python, they tend to get very strict about what they write. They want to be fast and not so verbose, for example. Thank you.
Fascinating. Do you have other questions? There's another one.
Would you have some ideas for metrics for developer experience, like how to measure it?
You mean how to measure how it's good to contribute? Like, or
how it's good to work with it, for example. How is it good to work with it, for example, if it's a framework?
I found that major is not definitive, but you know, major platform where people you know, discuss about the code are the most truth, I think. I think Stack Overflow is one of the many surveys that gives you a great example on how people tend to follow through a major, you know, things that need to happen. However, it's very true most of the time. How they progress, if they follow the technology, it's easier to work with. Or they're gonna keep following it for more time. Like PHP. PHP, it's a great example. It's here for decades. Probably it's older than me, probably. However, since it's easier to get ropes, and the people around it develop code that it's easier to understand or to develop on, you find that that language, it will stay up. Sorry, it stays up in the charts, you know, or the popularity of the language. It stays way up than the others, the next big idea. Like Go, for example, one of the many.
Okay, thank you very much. So this was the last talk for today in Developers Track. Thank you, Tommaso.
Thank you very much.
And so for the closing, Matthias Kirschner from FSFE will tell us a fairy tale about software, skateboards, and raspberry ice cream. Maybe he has some. One thing we will ask you is to come a bit forward, because it's a fairy tale, so, you know, we should be all in a group here.